So let's get more practice on calculating these kind of problems, okay? So first of all, we are going to find Kc in this question, okay? So what do we have? We have concentration of COCl2 is this certain value, and the concentration of CO and Cl2 are these values, okay? So we need to find Kc. So how can we find Kc? Remember the 3 steps. First step, we put down the equilibrium expression, okay? Okay, and then we substitute the corresponding values, okay? So CO 5 times 10 to the power negative 4 times 5 times 10 to the power negative 4 divided by 3.0 times 10 to the power negative 6. And what is the value of Kc? Now let's calculate the value of Kc, okay? So 5 times 10 to the power negative 4 times 5 divided by 3 times 10 to the power negative 6 equals 0.0833, and then this will be the second step, okay? This is second step. And the third step, what is the third step? Unit, right? Unit. So how can we find the unit? We have 2 mole per dm cube in the numerator and 1 mole per dm cube in the denominator. So after cancelling out them, we can have mole per dm cube, okay, as our unit. So we have finished this question, okay, understand? So the next question is that a mixture of 2.5 mole of H2, 5 mole of I2 is placed in a 5 dm cube. This is the volume, okay? Volume. So we have number of moles and also volume. So what do we find? We can find concentration, right? So we put down the equation first. H2 and I2 produce HI. So the equation should be H2 plus I2 in equilibrium with HI. So is that balanced already? Not yet. We have 2I, 2H, but 1I, 1H. So we need to put a 2 over here. Okay? So now we put down the row first. This is initial, and then we have change, and we have at EQM. Right? So what is the initial concentrations? For H2, it will be 2.5 number of moles divided by 5, the volume, okay? Equals 0.5. For I2, it is 5 mole divided by volume of 5 dm cube equals 1. This is 0, right? So, at equilibrium, concentration of HI equals 0.934. So this is 0.934. So what is the change? The change is actually positive, 0.934, correct? However, these two, the changes of these two would be very important. If you are careless, then you will get the whole question wrong. Why? Because 1 mole of H2 and 1 mole of I2 forms 1 mole of HI, 2 moles of HI, okay? 1, 1, 2. Can you recognize that? So, the change in HI would be the double of that in I2 or H2. So this is plus 0.934. So this is minus no matter, right? Because this concentration decreases and produce this one. So we are having negative 0.934 divided by 2. Understand why? Because this 0.934 should be the double of this, the double of this. So we need to divide it by 2. So 0.934 divided by 2 equals negative 0.467. And similarly, this will be negative 0.467. So we can find out this 1 minus 0.467 equals 0.533, and this one would be 0.5 minus 0.467, which is equal to 0.033. Understand? So we have finished filling in the table, and now we need to calculate the answer. So first step again, we need to put down the equilibrium expression. It is HI. Okay, now please remember this is 2, so we have a 2 over here. We have a square over there. Okay, over and I2 EQM. And we substitute the corresponding value, okay, 0.934 squared over 0.033 times 0.533, which is equal to 49.6. So what is the unit? Now, first step, this is the first step again. First step, this is second step, and the third step is calculate the unit. Okay, what's the unit? Here's 2, here's 1 plus 1 equals 2. So they cancel out each other. Can you see that? Because the numerator would be mole per dm cube squared over mole per dm cube times mole per dm cube. So they cancel out each other actually. So we don't have any unit. Okay, no unit. So the answer would be 49.6, and that's it. Okay, so we have completed this question, and no problem. Then move on to another video and continue to have some more practice.